Hello and welcome everyone to the Ask an OpenShift admin live stream. This is episode 145. Today we have our special guests, Chuck and Eva from IBM Turbonomic, to talk about how we can do all kinds of awesome stuff with Turbonomics with moving VMs and pods and containers and stuff like that across pods across our clusters. You may notice that Sully is not with us, and that is because he is unfortunately not feeling well. So Sully, if you're watching after the fact, I hope you get to feeling better, and we'll see you, in the new year. Real quick before we get started, though, our we're not going to be streaming for the rest of the year. So this is December 18th. Next Wednesday is obviously Christmas, and then the next week after that is the New Year. So we'll be back on the 8th. We don't have a topic yet, but we are working with a couple of folks to try and get some stuff scheduled and really start getting that new year planned out. If you have any tips, ideas, thoughts that you'd like for us to stream, please feel free to email me, Jonny at redhat.com, or Sully at redhat.com, SULLY at redhat.com. And we are more than willing to take them under consideration. We'll go and harass the product managers to try and get the right people, or hopefully Peter will put us in contact with people when we meet them at conferences, and we can make stuff like this happen. Like we've been very fortunate the last couple of weeks, so very excited. If you don't celebrate Christmas, if you're having some time off, whatever it is, I truly hope that you have a great break and that you get some time off, that you're able to recharge and come into the new year ready to go. Because I know that for Sully and I and my team and our teams in general, like it's coming, right? Winter's coming. It's about to get really busy again, and it's exciting. So looking forward to it. So Eva, I've realized I just said Eva. It is Eva, right? Not Eva. Eva.
It's whatever. Yeah. It doesn't matter. It's Eva, Ava. There's a whole story behind it. It's only 3 letters. Doesn't matter. It's all good.
Okay. Well, I relegate to you to please introduce yourself, and thank you very much for coming on.
Oh, it's our pleasure. And as you said, I work at IBM Turbonomic. My role is one of those product managers that you should chase. And I am focused on how to take our analytics capabilities, which we'll talk about. We have a little fun presentation to kind of introduce this topic. But basically, we're an analytics engine. How do we take those analytics and apply it to resourcing problems of compute, storage, and network? And 7 years ago, we took this analytics engine and we applied this to Kubernetes applications and platforms. So I've been working with Red Hat for 7 years. I think we had our first certified operator back in September of 2017. So there you go. Nice. I remember that.
Nice.
Yep. And we're big operator supporters. And I'm just excited to talk about chickens and pod moves. And then all of this is made possible through the smart people like Chuck who write the code. I just get to talk. Chuck, please introduce yourself.
Hi, everyone. I'm Chuck Lamb. I am a software engineer from IBM Turbonomic. I have been working on starting my cloud native journey 7 years ago, with Eva. So it's been a lot of fun, and then it's a great pleasure to be here, and then looking forward to hearing a lot of things from you guys.
That's awesome. Yeah, thank you. And again, like it's cool how our technology has evolved so much. Like one of my favorite things to say probably all year, if I've said anything 1,000 times, it's probably been like evolve or evolution or some variant of those two words, right? Because it's really cool to see, like where we started just a few years ago, like Kubernetes, I think just turned 10 this year, to see it go from Kubernetes 10 years ago to where Kubernetes is today, and even OpenShift in the middle of that, right? IBM Turbonomic. I'm sure that you guys are probably in a very similar, like where you started, you're like, oh man, this is awesome. And then today you're like, this is really awesome. So it's cool to see. Just the community around all of it, right? Peter, especially Peter Lauterbach, knowing people like him, who knows people like you, to help get people like us in contact with y'all. I'm a huge fan of the whole thing. I'm a big Red Hat Kool-Aid drinker. I'm a really big Red Hat community Kool-Aid drinker. So like I'm I'm big on it. So.
You know, I got some gray hair under the Santa hat here, and what I've really enjoyed is exactly that community. When I go to KubeCon, I feel like it's a family reunion, and I hope we never lose that. Right? That real not just technical experts getting together, a real community that we are all marching towards the same goals. So, absolutely. In fact, watching OpenShift virtualization, we actually started in solving resourcing problems in VMware. And it makes me chuckle to think about going from P to V. Some of you youngsters maybe don't remember that, right? We went from physical to virtual. Ooh, virtual. Then we went to containerizations, and now we're bringing the pets onto the farm. When we talk about cattle, not pets, now we're bringing the pets in the same place where we're running the cattle. And I think that's always that is interesting. And I think that's what we want to talk about today.
Yeah.
It is. It's exciting. So let's turn it over. Let's get it going.
All right. So with the everybody who's on, if you don't mind, I'm going to start with the PowerPoint because I'm a product manager, and product manager stands for PowerPoint presenter. So that's because I do want to, as I bring this up, let's see. Are we seeing this? Great.
Yep.
Okay. And then Jonny, I'm just going to go into slideshow mode.
Yep. Perfect.
Excellent. So proactive performance and efficiency with pod moves, whether those pods are VMs or containers. And I'm going to first try to lay out this problem. I could be preaching to the choir here, but I'm going to try to do it with a little fun, tongue in cheek, because it's the end of the year and why not, right? Look, I don't have to tell everybody here why are we running applications on Kubernetes, because we see the benefits, our organization see the benefits of cloud native applications, and it is about elasticity. Of course, it's about portability, it's about agility, but I'm going to focus on elasticity. So Kubernetes won the war, right, of container platforms because it delivers on this promise of elasticity. And since cows are a little big, I wanted to do, instead of cattle, I wanted to do chickens. So what's the perfect world scenario, right? Kelsey Hightower, here's my application, just run it for me, right? And in that perfect world, we would probably have a lot of free range chickens running around, right? Let them land anywhere on the farm and your applications will run. But unfortunately, we know that applications come in a variety of shapes and sizes. And when you really want to run even single tenant, but we know multi-tenancy is a big pattern, you unfortunately still have to deal with these things. The node congestion, the noisy neighbors, running out of resources. But this is what we're really afraid of, people, right? We are afraid of that monolithic app that's actually disguising itself as a chicken, but it's a dinosaur. And not to poo-poo monolithic apps, but actually, isn't that what we're now starting to do too, with bringing virtual machines and having that as a first phase of adopting some of the benefits of the Kubernetes platform? VMs as pods, thanks to KubeVirt and Red Hat, right? So this presents some interesting challenges with resourcing. Not that we didn't have anything with chickens running around on the farm, but this is really the reality of what we're living in today. We have to cage our chickens. We can't allow free range chickens, right? We even have terminology that we refer to when we deploy workloads with QoS, right? Best effort, guaranteed, right? So our first step is that we start to cage these chickens. Now, what's the problem with cages? Well, isn't it the size of the bars and how many bars you have, and the fact that this is a little chicken? That cage really may be unnecessary. And then this chicken, this chicken's not a happy chicken at all, right? And this starts to compound when we look across these applications that could be running 10 or 50 or 150 of these types of services. Then there's also this question of placement. And so what do? Well, we add more layers into these constraints. We want these big cages to land in the barn. These guys we want to maybe put in a coop. But again, we keep looking at allocation definitions in these placement constraints. We tell this Kubernetes scheduler, I want a lot of requests, so that'll put me in the barn, right? Without any thought of actually, does this little guy really need to be in this barn? And then what do we have? We have nodes sitting out there that just running our little daemon sets. Maybe our daemon sets are bigger than the mice, but you guys are getting the feel of the analogy, right? So now we leave it to the farmer, our DevOps guys. He's the one carrying that big question mark. And how do I capacity plan for these things? I got to just rely on the allocation model. This is the reality. We rely on these allocation models because Kubernetes is self-healing, but it is not self-optimizing. And I know I'm going to have some chicken farmers out there go, but Eva, let me get through the story, and then you can but Eva me, okay? Because the Kubernetes scheduler inherently operates as, at the time of deployment, I read the manifest and I take these things into consideration. This puts a big onus on what's in the manifest and who's writing that manifest. It's some of you on this call. It's the developers. It's maybe even DevOps people injecting things into the pipeline. I have to have my crystal ball out and think, where do I want this pod to land and what do I want its specification to be? And that's where all of this onus goes in, and this guessing game goes into that fortune telling of then maybe my scheduler will put me here and then I can stay there in that chicken coop fat and happy, because there is no performance analysis after you start running to think about maybe changing you around, right? There's only evictions, right? So something's got to give in this equation. And usually what gives is that I'll just make bigger farms. I'll let these cages be big, and then I won't have a performance problem, right?
Yep.
Let's actually maybe take chickens out and let's actually demonstrate something here in a little bit more of a dynamic nature. Here's a simple representation of Kubernetes with nodes. We got to make room for our daemon sets, right? And now we have application workloads. I don't care if these are containers or VMs, right? They have different memory CPU profiles. That's what I'm trying to represent on these axes. And let's put some demand in the environment, right? Now, what's Kubernetes going to do? Is Kubernetes with the running workload, is it looking at that green space and saying, hey, on the farm here, can I optimize that green space? No. It assumes that you've sized your cages to think about fluctuating demand, to predict fluctuating demand. And this is the reality that I have pressure in node 1, cattle, not pets, right? Shoot the chicken. It gets a little dark. All right, never mind. So we're going to have an eviction because we have set constraints in that node to have a definition of a healthy node. So what do I do? So where do I put this pod now? Well, I don't have any contiguous green space in node 2 and 3, do I? This is my only answer. Set up your cluster autoscaler, pod pending, and we go on node 4. Maybe node 1 is still having some pressure. Is anybody else going to get put onto node 4? No, not inherently. Not until you have an eviction or HPA is going to spin up another replica, right? So I leave it to you to ask the question, to answer the question maybe. How do you safely defragment clusters? Did I say customers? I did. Clusters, while assuring workload gets the resources it needs. It is a equation of trade-offs. So if I want to move workloads around so that I can manage the trade-offs of performance and efficiencies, how can I take the approach? Well, maybe I can have some smart farmers, right? And they can go in and they can get their alerts, and then they start draining some nodes proactively. By the way, if you're out there, I know who you are. You've told me this, right? Eva, I actually respond to some alerts and I go out there and I start proactively distributing these, especially for my horizontally scalable ones, because I already have them running extra pods just in case, right? We could build smarter apps. We could build them and make sure they're completely stateless. And again, we could run extra replicas. But the strategy of running extra replicas, isn't that another methodology of inefficiency? Maybe for business reasons, it's not, but okay. We could have smarter platforms, right?
Mm-hmm.
Or we can think of this problem as a supply and demand economic problem, where you have fluctuating demand and you have the potential to have fluctuating supply. And how do you manage these in a continuous analysis of trade-offs? What if that trade-offs are also helping you understand the key factors of resource consumption, resource allocation, constraints, an n-dimensional problem, but each one of these things must be properly weighted, right? Because you don't want to set a threshold on memory and then you introduce a CPU problem, right? And you don't want to set myopic thresholds on each one of these things, because thresholds do not guarantee that you are analyzing across all of these factors and correlating them. These are not new concepts. Again, I started in the mainframe, people. It is. So let's actually think about that problem if we could apply some of these multidimensional analyses. So now when I have increasing demand, what I have is something that is going to make use of the farm, better use of the farm, and redistribute so that each pod has the right amount of access to resources, not just allocation, but introducing actual utilization, and that the nodes are also in a healthy state. Let's just play that back again.
Can I ask, is this complementary to requests and limits? So I would still in my application set requests and limits, and then Turbonomic would actually take that and then use that to balance across the nodes. Is that accurate?
Yes, because we are working with the things that have been placed, right? And you still have the laws of physics of even deploying your workload, right? With the Kubernetes scheduler. And there's a role for cages, right? There is a role for cages and constraints. What I want to put in front of you, though, is that we have gone kind of cage crazy because we have to predict all of these things. We want our pods to land on the best node possible because Kubernetes isn't doing the next step. And this kind of continuous analysis under changing and fluctuating conditions to manage the traffic jam that happens. Gotcha. and actually be more preemptive so that I don't have to wait for evictions or something to happen, which is already an indication of a problem, right?
Gotcha.
Yeah. Go ahead.
Right, we're not only looking at the requests, right? Like you mentioned, Jonny. We also look at the actual consumption between the pods and nodes, such that, like you mentioned, the green space, and then so that we can make the best decision.
Right.
Gotcha.
Right.
Yeah, I think it goes back to like the evolution, right? When
Yeah.
you said a P2V earlier, right? And that's a great example as well. We had these huge physical servers that were running a service, or hopefully more than one service, but generally speaking, they were typically running one service, and you had this giant box for that. Then we had virtualization, and then it's like, okay, let me move this service into a virtual machine. But then people didn't really understand how to size those appropriately. So we were still sizing our virtual machines the same size as we had our physical boxes.
Mm.
And now we've evolved into container applications, and we're sizing your cages, right? Our cages now that we're putting around them, if we don't understand our application, we're blanket blasting a bunch of maybe more requests and limits than we actually need. And it sounds like this is saying, hey, that's cool. Here's some logic now to right size your cage and to better like use your compute power more efficiently.
Right.
Is
Right.
that, hopefully I'm not oversimplifying it, but that's kind of how like it's making sense to my mind, to me.
Yeah, Chuck, I would totally agree. I mean, and like Chuck said, utilization has to be an important aspect of that equation. And we've just learned, to be honest, right, over the 10 years, that we put a lot of heavy emphasis on allocation because we assume that utilization will just be handled by operating within the cage or these reactive mechanisms, but they are triggered that only after a problem is already starting. So we want to also be proactive. So I wanted because your audience is technical, I want to pull back a little layer here of what we're talking about and how do we achieve that. So because people are going to say, oh, you got AI. Okay, well, AI is a thing. All right, AI is a thing. But actually, we have something that is based on some principles that are actually quite elegant. And that is taking that supply and demand concept and applying certain principles to that supply demand algorithm that we're using. What we want to do is we want to converge the entire environment, the workload, the platform. The platform may be reliant on some infrastructure. We'll talk about how we model all of that in a minute. But what we want to do is converge things to a desired state. So what is that definition of the desired state? It is the trade-off that we want to drive utilization to a good definition of efficiency, but we don't want to drive it too high because there's not a linear relationship, by the way, of utilization and the performance of something that will represent as delay or some quality of latency here on the y-axis. And this is kind of based on queuing theory. So this is not a new concept. But if we think about driving up utilization, there's an inflection point where all of a sudden little bits of utilization could have a larger consequence of slowing things down.
Right.
Right. Now, this is what we call our sweet spot. Mathematically, that's a range for us in our algorithm. Now, things that I'm telling you people, I mean, it's a platform. It's been around 12 years. We got all sorts of knobs. You could make a career out of tuning the knobs. But let's just talk about, let's just talk about what we inherently have designed. And that is, this is about also protecting the node, right? We want to keep the node in a state which is a range, a plus or minus, let's just say it's again, it could be adjusted, but 65 to 75% utilized. We can still let the node go up to 99% allocatable with requests. And this is about managing those dimensions, right? But we also want to bring actual utilization into the picture, but we don't want to bin pack. We don't want to drive that node up to 99% utilization. because now you are in a risk place, right? Now you are in the eviction zone. Once you get above allocatable capacity, you are in eviction zone and you deserve to be there, right? We want to drive happy nodes and happy pods, but we don't want them down here because that's where most people are operating today. Why? They look at their nodes and they say, I'm at 99%. You're 99% requests. What about your actual utilization? No, it's fine. No, it isn't. It's 20% utilized. You're out there, people. I know you are. I walk into these environments and they are 90+% full with requests, but their utilization is often less than 50%.
Yeah.
Because why? I got to fit the cages, but nobody looks at the size of the chicken inside of the cage, right? So how do we leverage that queuing theory and now apply it to a supply demand problem? Well, let's talk about the definition of supply. It's my nodes, right? My nodes have metrics. And what we do is we take those KPIs and we commoditize them so that we can have equal weighting. So we look at percent utilization. We have capacity, we have usage, we have percent utilization. So these KPIs all count equally, right? So commoditization of metrics. And then we're going to give a cost, a virtual currency of running workload on that node. Now, what are the factors of the cost? This one is going to be expensive because this one's probably got a lot of chickens already inside it. There's a lot of utilization. The allocation is high. So the cost is high to run here. These guys, maybe not so much, right? Not so much going on. So now, Eva, how do you make the decision on how to move pods around? Is it just purely based on the cost of running that node? No. I got to look at every single pod and I got to look at the dimensions of each of those pods. I got to look at the cages that are placed on it. I got to look at the size. I again commoditize the KPIs of each pod that is running and I give it a budget. And that pod now has money to go shop for the best place that it can run. And in this supply and demand equation, what we do is we calculate an ROI. Now, I am oversimplifying this right now for everybody, but I wanted to expose some key principles because we must take constraints of allocation, we must take constraints of utilization, and other constraints, such as what if this chicken, while it could really almost run anywhere, right? It's got a low budget, it can fit here, it could probably fit here. But what if this chicken has an expressive node selector? Well, while this could be cheap, this one would end up being infinitely high to actually run there because a constraint is another dimension. And I just ran out of PowerPoint space to actually reflect those things. This is the n-dimensional problem that our software continuously analyzes for. And we do this analysis. I just showed you a supply and demand of a pod on a node, but we actually represent a full stack, a JVM on a container in a pod, or a JVM on a VM now in a pod on a node in some infrastructure. That
Gotcha.
supply-demand relationship actually goes through that full stack, which is also for us a way that we validate that an action is executable. Because we simulate these chickens moving around, which could also mean I may need another node. All of that is done through this entire supply chain representation. So that's what makes the analysis robust, but then we also need to hook it up to an action execution mechanism. And I'm going to pause now because now I'm prepared to kind of show you a little video about this in action. But if anybody wants to talk a little bit about the analytics, I could
We
stop.
do have a question.
Okay.
Yep. So the question is, is there a tool that can validate namespaces to see if it's overcommitting in the way that you're discussing, so that we can treat them less lenient than namespaces that actually are good Kubernetes citizens?
So that's an interesting question, because I would say, you know how we've tried to do this is that we bring another cage into the picture. So we have layers of cages. We call them quotas, right? Resource quotas.
Mm-hmm.
I ain't a fan of resource quotas because I think they are again used as another allocation tool. So I would say, and maybe this is a discussion that we could even double click on in another session, but I would say, you know what we need to lean back into is a little more free range chickens. And we can't have them completely without cages, but we should maybe start to loosen some of the bars on those cages. So I think validating at a namespace to me is really maybe really the intent is here. I just got so many applications. I need a better understanding of what each application is really doing. Sure, Turbonomic can give you that contextual slicing, but if we want to talk about distribution of workloads, a namespace is a virtual construct, right?
Right.
I think you should really take a reality check on how are these workloads actually utilizing resources. And I think pod moves are a DevOps secret weapon. I don't think you need any permission from an application owner to say, your pod should not be running here, it should be running there.
Yeah.
Right.
They should not be in the business of dictating which node. Now, if they have physical requirements,
Right.
then sure.
GPUs, et cetera. Yeah.
But put them in a node pool then. And
Mm-hmm.
again, don't let them dictate. They should just be free to run anywhere in that node pool, right?
I like it. I like how you put that, right? And I think it goes back to the original idea. You,
Right.
as a DevOps engineer, should not dictate to an application owner what language to write their application in, how they should write their application, how you build that app. I don't care. That's on you. You just tell me where you just give it to me, right? And
Right.
then vice versa is, as an application developer, you don't tell me how to run the farm. Right? You don't
Right.
tell me how to run the cluster. And then we've got two, mindsets here, and it's like DevOps is kind of combine them a little bit, but at the same
Yeah.
time, it's like they're different roles, right? There's a reason why
Right.
there's an infrastructure person and an app person, and like they can be similar and like they could be on the same team, but there are times when there is there's a line in the sand on roles
Yeah.
and responsibilities. Yeah, it's a good point. So.
Yeah.
And you know what's funny is that if we look at VMware, right?
Mm-hmm.
There is a VMware sysadmin never asks the application owner when to move vMotion, a VM, right? It is a mechanism. It is the arms and legs that make it possible to redistribute workloads. It just needs a brain. And really, that's what Turbonomic has been. We are brains, and then we leverage arms and legs,
Mm-hmm.
which is a little segue into now, if we move those pets onto the farm, those VMs onto the farm, we actually have something that we didn't have with container pods. We have something called live migration. And live migration is really missing the brains,
Yep.
right? It's again, when a live migration plan is invoked by a user, it is going to do the native things in Kubernetes, and it's going to prioritize requests. And what do we know about request people? We know they aren't telling the truth.
Mm-hmm.
They are not telling the truth. That requests are typically leveraged as a way to guarantee my maximum resources. Now, I know there are people out there who have been doing this for years, and they are more prudent with their requests. but I don't find that to be the norm. And now we put these pets on the farm, and oh my gosh, now we're like, in fact, the recommendation. This is where I kind of nudge Peter and I go, "You're telling people to set the limits equal to the request, aren't you?" And he's like, "Yeah, because you're afraid. You're afraid nobody wants their pet evicted." They were maybe willing to tolerate some chickens getting evicted, but nobody wants Fido evicted from the farm, right? And ironically, we've got this mechanism, so now we need the brains. And this mechanisms that I've been talking to you about fit perfectly with that confidence. So Jonny, you know what we're about? My Christmas present to the Kubernetes community is, or my holiday present, is I want you to have confidence to run chickens and pets on the farm and not have to take valuable resources like DevOps people to sit there and do this Tetris game in their head and go, oh, should I move that VM and should I move it now? And should I drain that node now? And will I have a congestion problem? I don't know. Let's just hope it all works out. And I'll just add more resources until somebody goes, how big is that cluster? How much money are we spending here?
Exactly. That's the thought that came to mind earlier. Like when we were talking about scaling out, it's like eventually that bill comes due, and and yes, it's not good.
It's not good because we all love Kubernetes. I love Kubernetes, and we wanted it for elasticity, right? We wanted it for all of those business benefits, and we actually got ourselves into this world of that first phase of P to V, where not only were people saying, okay, I'm going to make my virtual machine big, what did they also do? They weren't overcommitting. Heck no. Oh no, I can put 4 into this ESX host. That's all I'm going to do. And what did they learn over time? They learned overcommitment was not the evil empire, right?
Yeah.
But if you have the right brains and analytics to manage the trade-offs, this is where Turbo started. We are the better DRS for VMware, and we have been that for 12 years. And when Peter Lauterbach came to us 2 years ago and said, I want you to be the DRS for Kubernetes, I said, we've been moving container pods for years, Peter. We can move your VM pod.
Yeah.
So maybe if the community's is okay, let me actually just show you a little video. This was something nice that Chuck put together because we wanted to prove it. You know, we wanted to prove it out with VMs. But ironically, the analysis had been there for years, and we've been doing this. So is it all right if I just go and I just show you now a VM pod action execution?
Yeah, let's do it.
All right. Entire screen. Are we good?
1 second. Now we are good. Let me do this
Okay.
part. Bam.
Is it good resolution good?
It looks okay to me. Let me see what the. Yeah, I think this looks good to me.
Yep. So let's just play this video. And again, I think you'll also see kind of like a simple view of the supply chain in action. Let me just orient you quickly to, this is the Turbonomic UI. And here we have a virtual machine kind controller represented with the specifications. We can talk about why in our model we split these out, quite frankly, so that we can drive multiple types of optimization decisions of sizing and placement and even horizontal scaling all at the same time, right? We created this, what I call the 4 corners of container or virtualized, containerized workloads. And this represents what's actually running, and this represents the definition of the parent controllers, right? So then here we have a pod, the container or the virtual machine image inside of the pod, the namespace, again, organizational construct, the cluster itself, the node, and then of course, if I had, there's going to be other representations around this. So let's just play this video. Oh, and then here's an action, and we have other supporting information, including we've got data. We can show you history. We can show you what's going on right now. And what's interesting here is that we're actually starting with this virtual machine kind with a resizing action. We actually have a resizing down of request and CPU request, mem request, and mem limit. So that's already there present for you. But we're just going to actually move into introducing some congestion and moving something around.
So, Eva, real quick,
Oh,
I'm assuming all this information that we're seeing in this UI right now, right? Is that something that I can scrape through like a like an API or something like that? Basically, can I configure it through like a YAML file, through a manifest, or is it all like GUI driven?
okay, great question. And so there's a mixed answer. So in short, everything that you see is made possible through a REST API interface, right? So
Okay, got it.
Yes, you can query Turbo and pull this information. We are, to indicate the throttling, my second favorite topic. And Chuck actually built in Turbonomic a representation of CPU throttling in our data model. You know what? If you want a January 8th topic, we could spend a whole hour talking about throttling. In fact, could I ask you, Chuck, please, to put into the chat the link to your article on how we capture, calculate, and remediate throttling? That was a great question. That got me excited. So, okay.
Yeah, let me put it out there.
Yep, we'll put that link out there. So, but yes, it is part of the analysis. Now, for us right now, throttling is handled through better CPU limit optimization, but we are, so we'll come back to the right sizing. But yes, it is a function that we can actually represent. So yes, here we are showing you that this is the current snapshot capacity that's defined, the actual usage. We have an action here right now on right sizing. We're going to show you supporting information when you drill down into an action, by the way. These are common constructs of how you interact with the Turbo UI. I think here we are taking a right sizing action right now. So we're going to actually go through and see that right sizing action. Maybe I pulled up the wrong video. Chuck, I think this is the, this is going to be the right sizing one. And then we'll see the spec change happen, and then that'll be updated. And then Bob's your uncle, as the Brits say. So let me actually go into the move action. Oh, let me stop sharing. Sorry, let me just stop sharing. But that gave you a high-level overview of an atomic action over there. Let me now go into. Oh, sorry, I actually brought up the wrong video. Let's see the move action. Let's see, Chuck, where did I have the move action? Do you happen to have that link, by the way, Chuck?
I have that video.
Oh, yes, here it is. Sorry.
Okay.
Sorry. Let's bring up another one. But that was a good orientation to our product.
So can you set it to automatically apply the change instead of, because
Yes.
like that looked like it was like, hey, I'm letting you know that here's a thing, and then you went and approved it. Now.
Yes.
Okay.
Yes. Because to actually get the feel for Turbo, we always start with a discussion about, do you like this action, right?
Mm-hmm.
So it always starts in a recommend or manual mode only. So yeah, now going into specifically around OpenShift Vert, this was our motivation. We wanted to basically bring the analytics of dynamic resource balancing to the arms and legs that are made possible with KubeVirt. And then this is the gap that we fill. And again, we've been filling this gap for 12 years, by the way, even in virtualization. So now here's the same, now that you've been oriented to the supply chain, now this supply chain is actually pulling out, and now we're looking at a group of nodes that are dedicated to running VM workloads, right? So now you see that the supply chain started to build out. We have 3 nodes here in this cluster. There's 16 namespaces that represent workloads that are running across these 3 nodes, 142 pods, 87 parent controllers, and we've got some PVs. Why? We all know that to run VMs on OpenShift Virt, there's going to be a read-write many PV that's going to be attached to it, which actually makes the live migration possible. And when we look at these 3 nodes, we do see some uneven distribution here of demand, and we are actually focusing on the CPU utilization. Request allocations are different, but the utilization in these high request allocations is very low, right? Mm-hmm. So let's see how we manage all these trade-offs. So what the analysis is doing is we have actually made a recommendation to migrate a VM from worker 0 to worker 2. And we're giving you a little bit of a projection on if you took this action, what will be the end, what do we project to be the utilization on these nodes once this action takes place. And then what we do is we can actually execute this action. So the execution is basically, we're going to hand it off to live migration. So we're going to execute this action, and underneath the covers, if you see down below, you can see that a live migration plan is actually invoked. Turbonomic is going to interject a node selector that is going to place that migrated VM on, oops, sorry. Let's go back actually here. We're going to place that. I'm going to pause it right there so that, oh, sorry.
A little bit
further.
Yeah, before this. Yeah,
right here. Yep. Right. So you can see that that is transitioning, right, from migrating. So basically what Turbonomic did was, under the covers, we invoked a live migration plan on that specific VM and instructed it where to actually place that VM. And the result of that is that we drove a better distribution of workload, and we potentially mitigated on that worker 0 in eviction.
Mm-hmm. So Eva, on the I think it was like one of the previous screens where it's like, hey, it's telling me what like your gains, right? Here's what this is going to do once it balances. Is there a chart or a graphic after the fact that says, hey, you went from, that basically shows this right here, right? That shows like, hey, I started here, I ended here, that you can go and use, because to me that's quantifiable as far as like when you're trying to tell an application owner, like, hey, this is what's going on. Here's what we're seeing. Historical data, I guess, is ultimately what I'm trying to get at, like that you can take back, because this is awesome.
Yeah, in fact, this is, so we can actually see these things from a perspective of, I can look at the node pool, I can even look at the cluster, I can aggregate across these and just look at the resource demand overall. But at a node by node level, I can look at the history and say, look, we had these. And basically what you're doing is you're trying to quiet those peaks that are risks of, performance issues and risk of what would be for a VM pod a very bad situation of getting evicted, right?
Yeah, that's awesome.
Absolutely. In fact, one of the things that we can do is that we can actually simulate taking this action, and this gains confidence. Turbonomic has, you're looking at something with what I would call the real-time recommendations and also the real-time action execution. But I have something called plans, which you can see over here on the right-hand side, that I can simulate a plan, little plan icon. And what does a plan do? I can target that cluster and I can say, take all these actions for me right now. And what does that do? That simulates taking these actions in a snapshot in the environment. So no chickens or dinosaurs are touched in the making of that plan. And that is actually the stage to which a lot of customers go through to get the confidence in that this new thing of proactively redistributing workloads starts to become trustworthy.
Right.
And we are big on the trustworthy thing, right? That's the reason we have the supply chain, because we don't want to make a change that would introduce a problem in another dimension, but also in even just believing that the action is going to generate a positive outcome. We run a plan. And by the way, you could say in the plan, don't resize. That's another discussion I have to have with all of these app owners. I have 300 app owners. I'm not sure I can get them all on board at the same time. Just move the workload around. Or you could even do the combination effect of moving and resizing, because resizing could unlock more capacity in the barn, right?
Yeah.
So yeah, planning.
And it's quantifiable, right? That's what I liked about that. And just from I'm sorry, I didn't mean to cut you off there. I apologize. But just listening to it, right? There's a lot of times when we go back and we say, hey, you need to do X, right? Whatever that action is, you either need to put, request limits on your application. You need to build your app better. You need to size it appropriately, whatever it is, because at some point you hit a budget box, right? Like you were talking about earlier.
Yeah.
Like you end up, the bigger chicken coop ends up saying, hey, we're out of money. Like you need to be fiscally responsible with like your infrastructure, right? Or whatever it is. But to be able to go back and say, hey, look, here's what we get when we do this. Not Jonny thinks that you should do this because Jonny says this. It's here's the data that backs this up, right? Here's what we see.
Right.
Here's what the nodes are doing. Here's what it's going to look like when we make this change. And here's what, basically here's the net effect of like what's gonna happen. And
That's
being
right.
able to have data to back it up is much better than, well, Jonny feels or Jonny thinks,
Right. Right. And in our planning, we also allow a user to simulate these other scenarios, because we may have a farm over here that we want to take some of our Rhode Island red hens and move them into this cluster. And I'm being a little cheeky, but this is the classic. I'm using my clusters as definitions of environment. So in an application, application promotion from non-prod to prod, how do I know that I've got enough room in the barn for more chickens, right? And I can simulate that. And part of that simulation is the impact of, well, they didn't actually resize when they were in non-prod. So if I don't resize, I got to buy 3 barns. But if I do resize, I might even be able to save off a chicken coop, right? So I think these are powerful what if scenarios, but the fundamental basis of it is this concept of the supply demand equation and bringing real utilization into the picture and using utilization and not just allocation models to kind of optimize the whole estate, because you can't just optimize the cage. You really have to optimize placing the cage, moving things around. Because when you're in a traffic jam, you can make the argument that you shouldn't have one person inside of a big SUV, right? And you should have more people in a car. It's kind of too late to make that argument about sizing the cars. You got to move things around so that you don't end up being late for your appointment, right?
Right. Yeah, the promotion thing, I didn't even think about that. Like when you're moving between environments, because like we always say that it's exactly the same, or like, hey, they're similar, but to actually have no, okay, now they're the same. Now this is what it looks like. Here's what it actually looks like when you do this, instead of like using hope as your last resort of like, okay, I hope it deploys. It's gonna be amazing.
Yeah, because and our hope, how do we do hope? We hope based on allocation, right? So we go back to the formula of, well, if you just guarantee what you think you need, then somebody's going to ask the question, how much is this cluster costing me now?
Right.
And this is true for on-prem as well. In fact, again, I'm a big proponent of, there's nothing wrong with running bare metal clusters, right? Nothing wrong with it. Hope is not a strategy. You're right. Hope is not a strategy.
Absolutely.
And allocation is not the best strategy either. Allocation's great if you've got a blank check, So, again, we were talking about, by the way, this environment, we are walking our own talk. IBM has an environment called TechZone, which is an internal sandbox where I can spin up OpenShift and I can play with OpenShift. I can spin up Cloud Pak for data. I can spin up Watson, which is, really heavily leveraging AI portfolios. And I can play. Well, a lot of these things, obviously, right, run on OpenShift clusters. Well, we have our own little challenges too of 289. And by the way, this is only 1/3 of the environment. 289 clusters, not all of them are actually optimized, are they? So what we do is we drink our own champagne, that we do real-time optimization so that when we bring these assets up, people have a good experience, but we're not breaking the bank just to have somebody play with OpenShift for 3 days and then shut it down. So one of the things, again, here's a little bit of our planning simulation. Let's say I want to by the way, I'm doing this free bird style, so I don't know what I'm picking here.
It's amazing.
I'm just gonna pick this cluster. Now here's that concept of the optimization. And again, I'm focusing everybody on this plan simulation because I think it's inherently interesting. So here, do I just want to optimize sizing, or do I just want to optimize placement? Or do I want the full enchilada? I'm going for the full enchilada. And let's see what happens. I don't know what this one's going to actually turn out to be, but this is that capability that I was talking about, and that other plan simulation that we were talking about. Let's see if I can, let me duplicate this tab here. That other plan type, here's that migrate, right? This migration is like, okay, here's all your work. Now this is where we are using, the namespace concept, because we thought, okay, let's start with workloads to migrate just show namespaces and clusters, because that's kind of how people do sort out one chicken from another, right?
Right.
By the way, I have no idea if this is, so this is B3. Then I'm going to say, where do you want to migrate this to? Well, let's migrate it to here. And again, I could skip to configuration. I can do things like, oh, I think we're going to have a lot more of these, when we're actually in production. Again, I'm literally flying by the seat of my reindeer here. So I don't know. I don't even know what I'm doing. So, but all right, let's run that as well. And I'm taking advantage of all of this analytics to kind of give me that visual of what I probably should have staged this before we started this. But what is my outcome supposed to be, right? And maybe I know we're at the top of the hour, but we'll just let this run for a little bit.
I keep doing it, and I don't mean to. I'm sorry. I'm not. I really, truly am not trying to be a jerk and cut you off.
No, you're not. I could keep talking. I could just keep going. You got to stop me.
Okay,
Yeah.
my bad. And no, Our Hope 9 made a great point about it. It's rare that people find their application bottlenecks using pen and paper, right? Like trying to do public math or napkin math. Like you might get lucky every once in a while, but generally, like, you actually need to use tools and take data and make decisions based off of that versus like assumptions and paper math. So
yeah.
And you even saying, how do I line these things side by side? Well, here's a good way of kind of seeing that. So this cluster, there we go. I could save 3 nodes, and I'm showing you that I could even reduce my memory overcommit, by the way, because even my memory limits were too high. The increase in CPU overcommitment is made possible very likely by CPU throttling resizing. Don't just believe me. You can see here's this list of actions that I've been taking. Here's the CPU throttling congestion, right? But that results overview is I'm showing you kind of the before and after picture. And you could see that I just didn't have very good optimized distribution of my workloads. And I can start to run these better while keeping the constraints and the trade-offs in mind. Some of these nodes are probably lower in usage because they could be master nodes, right?
Mm-hmm. Mm-hmm.
We don't want to drive those up, right? Yeah. These are very much likely that these are master nodes or infra nodes. This is actually storage one. This is an infra. I think that's what you were saying, Chuck, right? There's your masters right there. And for the compute nodes, we definitely could optimize the number. In fact, I think these are always going to be only compute nodes that are going to be, we never scale down master nodes, right? That would be
right.
Silly. Right. So yeah, that's how we prove it. And you didn't have to take any actions. You just simulated it. I could download this. I could share this as a PDF by taking just a screenshot because it's just a web app, or even just doing a file, file print, right? And taking this and sharing this out, right? All sorts
That is
of
awesome.
before after comparisons, right? And same thing with over here. Actually, what's interesting here is that this is telling me I didn't reduce any nodes, but I could absolutely run all of those workloads in that cluster without adding any nodes. And driving up utilization of a cluster smartly with confidence is also a good use case, right? So this was my migration one. This gave me the before and after. I got some nice density increases, and there you go. And I was able to maintain good density didn't need to add any nodes. And it's maybe a little hard to see this here, but I actually even reduced my request allocation. That yellow line there is CPU request. This is the lift and shift, and this is optimized. I was able to drive some better memory utilization without introducing risk, and I reduced the request allocation, which allowed me to run more pods on that node without getting outside of that desired state.
That's awesome. So I have two questions. They're both they're related. So the first question is, how often does does Turbonomic check the pods? Is it constant? Is it anytime something's deployed? And then the add-on to that, it leads into that really, is like how, like we have the burst, right? So maybe we're spinning up a bunch of applications. So maybe we've just hit like a big demand, right? And so then our HPA is starting to spin up pods, right? Well, that pod initially takes some of that burst compute, stuff like that. So how does it handle like the burst over time? And then it's basically like how does it handle a CPU spike over time? Hopefully that made sense.
Yeah, and I'm just going to give you a high level, and then again, we got Chuck here on the phone. In fact, I would like Chuck to talk about a project that he is doing with our IBM internal team that is working with a lot of inferencing workloads, and our definition of horizontal scaling, because our definition of horizontal scaling isn't the HPA, react to a threshold, throw it over the fence and say, hey, order me up another replica. I hope you can actually schedule it, right?
Yeah.
We actually project that we can schedule that, and then we allow the action to execute. And then or if we can't, we need another node, we actually block the execution and you see a node provision. And so we can proactively spin up a node without waiting for eviction, or pod pending, I should say, right? But it's a continuous asynchronous analysis, but it is done in 10-minute blocks, because we want to be smart about actions. We don't want to we have an ROI for our actions, and we don't want to get into a race or flip-flopping around.
Right.
So I don't know, Chuck, if you want to embellish more on that.
Yeah, to that point, that the flip-flopping, I think to Jonny's second question, that how to accommodate the burst and the peak, and then one of the algorithms that we use is to call percentile, and we have different algorithms, and then to basically observe the historical data, look at it like 7 days, 30 days, and then to learn about a pattern, and then to decide that what is the best sizing for your application, so that you don't just respond to a very tiny peak and then stay there. But if you have a very substantial kind of burst, then we will take that into consideration, and to put it simple like that. And the algorithm that we use will accommodate it. And then, like Eva mentioned, I have the really privilege of working with the IBM researchers, and then to come up with even more advanced and scaling algorithm using machine learning AI, prediction techniques that to help us to make a better decision, and not just rely on a simple threshold, which I think it will work if you keep tuning for every application, thousands of them. But we are fighting for coming up with more intelligence automatically to help you hands off.
That's awesome.
Yeah.
Okay, that answered my question perfectly. I appreciate it. And our Hope 9 has another question. Does it also take I/O latency versus the storage class into account, since faster disks can have a huge impact on CPU weights?
Actually, so that's a very interesting topic. What I will say is today what we are doing is we are, because the native Kubernetes CSI doesn't really give you IOPS. You can see the right. So this is part of our benefit of our supply chain, actually, that I think the best example is, let's say I'm running Rosa, right, in AWS. And actually what we can see is that a PV, I get this information from either the public cloud provider for IOPS, or if it's virtualized OpenShift on VMware. So, and I can stitch this information together. Today, one of the actions that we drive, our hope is that we can drive making a definition of a better storage tier to use for IOPS. And believe it or not, under the covers in AWS and Azure, and I believe also in Google, you can actually change the PVs or the volumes tier type, and Kubernetes doesn't care. So Kubernetes says, I don't know, I'm stretching my, so what is it, GP2, and you could go to GP3, and you change it to GP3, Kubernetes still sees the PV as GP2. It doesn't matter. So we can actually even automate changing the storage tier to get better IOPS cost performance, made possible by the cloud providers, because what you're really changing is that block or volume, right, on the back end, and it doesn't upset Kubernetes. Now, ideally, we would love to see, very interesting. Ideally, we'd like to see more in the CSI about storage, latency performance, and there could be some interesting use cases around that. But that's actually how we handle storage congestion, is that we can make a better storage tier recommendation and execute it from the outside.
And to add to what you said by Eva, so our analytic model is very abstract. So as long as we get the metrics, this is a matter of getting the metrics into the model and then we'll come up with the appropriate analysis as Eva was describing at the beginning. If, for example, we're not getting some of this storage metric from CSI, Eva mentioned, we can get it from the cloud provider. And another mean that we can also, we have a way that to also get it from, we have something called data ingestion framework so that we can get it from Prometheus, for example, and then pump in the appropriate metrics into an analytic model, then it will come out with the appropriate recommendation for you.
Yeah, so here's some Here's some examples that I've got here. And you can see that it's not only for the PVs, but we could also even make better decisions on the root volumes for the nodes, right? Especially like in a master node, if etcd's a little having some problems. I mean, we could make that decision and execute it.
Yeah, and Kubernetes uses a lot of PVs, right, and on volumes. And I just want to add a point that some of those high performance, high ROR volume are actually pretty expensive. So if we can, let's say recently that we they help some clients and analyze their really the usage, and then we find out because they heavily hitting the caching, right, for high, great career performance, the chance that they're hitting the disk is actually pretty minimum. In those cases, we could help them to save a lot of money by using a slightly different, more, less expensive disk type. That's a huge saving, like $1 million.
Yeah, that's low hanging fruit. It really is, because people that spin up their clusters, I think that they're, for the most part, are just providing one or two basic storage classes, right? And like Chuck says, and everybody wants the best for our little chickens, but it's not always necessary.
Interesting. That is super interesting to me, because that's awesome.
Yeah. So, I guess in summary, what we wanted to kind of have as a takeaway is that the representation of this supply chain that we have over here is actually continuously driving this supply demand algorithm that we have, that not only makes for better decisions, but actually makes dynamic, intelligent redistribution of workloads to be more preemptive to mitigating performance risks while looking for efficiency opportunities. And it assures that the action is executable, meaning I'm not going to do something unnatural that the scheduler would never allow, right? Because I'm basically going to hand it off to the scheduler to execute the move. I'm just telling the scheduler which one and where's the best place to go, instead of relying on evictions. And even in the upcoming, what descheduler is doing, descheduler is not actually doing any sort of real holistic continuous analytics here, right?
Right.
But Turbonomics data model and algorithms are actually simulating these things. And this is what drives better results. That's what kind of gives you the confidence to automate. And if I had to pick, over the 7 years that Chuck and I have been doing this, the first action that actually people automate are moves, because they don't have to ask an application developer for permission, but also they get immediate benefit. And when you are either in a traffic jam, or you're there's a few cars on the road and you got all these lanes open unnecessarily, you get some immediate benefit that you can demonstrate. And you're doing something that actually augments and expands that elasticity of Kubernetes, which is the reason we are all here today, right?
Yeah.
Because we believe in it, but we don't leverage it.
Yeah, it's awesome. Quantifiable, actionable data, right? Actionable data that's pretty amazing.
Well, That was my holiday story for this month. And yes, Virginia, you can move that pod. And no, it doesn't need to have a PV unless it's a VM pod, right? Um, I we actually did design a better mousetrap, and we have 7 years of real results with customers and looking at their Kubernetes environment in a whole different way.
Yeah, this was awesome. Like I'll be honest, like coming into this, I tried to be as ignorant as possible coming into it. Like I did a little bit of reading and stuff like that, but I was like, all right, I just want to hear it so I can ask dumb questions. But no, this is pretty amazing, and it just takes me back to when I was an infrastructure admin. And if Sully was here, I know he probably has 100 stories that are very similar, where you're trying to do the right thing by the customer and the application developer at the same time, especially as an infrastructure admin.
Right.
And it's a juggling act sometimes, right? Because the customer wants the ROI, right? They want to see their investment, right? The developer wants to see their application running. They want to get it in production. We want to make everybody happy as infrastructure guys and or infrastructure people. And yeah, to be able to go back and say, hey, here's how we can do this. Here's why this thing keeps blowing up or whatever it is. Do something, right? It goes beyond like again, like Jonny thinks this or Jonny feels this, right? It's quantifiable, it's actionable, and you can automate it. I think that's pretty incredible.
Yep. Well, we really appreciate the opportunity to tell this story. Ironically, a story that's been around 7 years, but the fact that now that we're putting pets on the farm with VMs, I think people are really looking at more closely like, oh, wait a second. Kubernetes self-healing mechanism is about evictions. We don't have that. VMware doesn't evict a VM, right? Are you kidding? I'm not going to put no, you can. You can actually run your workload on Kubernetes because there is an analytics engine out there that will manage those trade-offs and preemptively mitigate those risks without the answer of over provisioning.
Right.
Right?
Yeah. That's awesome. Yeah. Awesome. And yeah, thank you very much for coming on, like both Eva and Chuck. I really do appreciate it. It was awesome to meet you at KubeCon, Eva. Your energy is infectious. Like I'm high energy as well. So like whenever I get around other high energy people, I'm just like, yes, it's gonna happen. I gotta calm down. So no, it was great meeting you. And
likewise,
I really do appreciate you taking the time to come on. I know Sully. I don't want to speak directly for him, but I know that Sully would love to have you back on.
We want to talk about CPU throttling. That is one of Chuck's many little babies. And then we'd love to come talk about that. And then we also would love to talk about, this new AI world and what does it mean to run these models and these inferencing workloads. And of course, we want to think about, let's not repeat those patterns of, just scaling out because you have CPU at X%. Let's be smarter about how we scale and how we leverage, because GPUs are a little bit more expensive than farmland, right?
Yeah.
So,
absolutely. Yeah, and our Hope 9 just made it. He's like, if I've heard it once, I've heard it 1,000 times. Is that they don't want to figure out what's wrong? They just throw more compute at it, right? Like that's been the age-old adage for infrastructure admin since the cloud became like the buzzword of the year.
Yeah,
so,
right.
Excellent testimony. I think that's a great comment.
Mm-hmm.
Yes.
But so I'll reach out to both of y'all then and set something up, to have y'all come back on. So because I really did enjoy it. I learned a ton today, and I'm thankful for you guys being on here, and I'm in the spirit of being thankful right now. Where again, back to the community part of it, like I love it, and I think it's amazing, and I think that this kind of outreach is it's awesome. So thank you so much for your time. To our audience, if you have any questions or if you have any episode ideas that you want, that if there's anything that you want Sully and I to bring up or get a product manager on for, please reach out to us directly, and we will do whatever we can to make it happen. For everybody else, I hope again that you have a happy holiday or at least a happy break. I hope get away, take some time off, have some eggnog, play some golf, whatever it is. Do something. I hope you get away and recharge. And with that, we'll see you back in January. Thank you very much.
Thank you, Jonny. Thank you, everyone. Happy holidays.
See ya.